So here, welcome to the first topic in Unit 2. It's going to be centered around Newton's laws of motion. So this is his first law, but Isaac Newton isn't necessarily the first person to make these discoveries. You've got Aristotle, and after Aristotle you have Galileo, and then we come to Isaac Newton. So Aristotle some of his ideas are still around. Galileo is definitely some of his ideas are around, and I'll highlight those as we go. But so the first thing is this idea. So what is a force, right? So force is a push or a pull on an object. So any force that is talked about in dynamics is going to be a push or a pull. And then when we apply a force, right, there's going to be two quantities that we look at. There's going to be the strength or the magnitude and the direction. And the reason why is because force is a vector. So we have to account for the magnitude or the size and the direction that the force is acting in. Now, Newton's first law states an object will remain in a state of motion as long as there is no net force acting upon it. Okay, I forgot the quotations. So sometimes you'll hear an external force. Okay, so external means it's coming from outside the object, pushing it, pulling it, not necessarily on the inside. So when we talk about Newton's laws, we're going to talk a lot about systems, what's internal to the system versus what's external to the system. And what is external to the system will be what is pushing or pulling that system. The first law is often referred to as the law of equilibrium or the law of inertia. Okay, and when we talk about equilibrium, there's two types. There's static equilibrium, which means there's no acceleration. Sorry, not no acceleration, but no motion. Think about bridges, buildings, and so forth, right? You don't want an acceleration. You don't want those objects in motion. That's why they call them, a course in college is called statics. The second type of equilibrium is dynamic equilibrium. So what this means is that there is motion, but no acceleration. Okay, so this dynamic equilibrium will lead to a big misconception, the idea that objects can be moving without accelerating. So the misconception is objects that are moving are being accelerated. That is not true. Objects can move, okay, with no acceleration. It just says that they are moving with constant velocity. So if in a question you see this phrase, constant velocity, that means that we're in first law, the forces are balanced. And that's what equilibrium actually kind of means too, is balanced forces, right? And so the next thing is inertia. So the law of inertia, right, we talk about inertia being the measure of laziness in an object, right? So officially it's resistance to change in motion. Right? And so the physical quantity associated with inertia is mass. So big mass equals big inertia, right? So objects are going to resist motion or changes in their motion more if they have heavier masses. So think about semi-trailer or semi-truck, semi-tractor trailer versus smart car, right? Who's going to resist the change in motion? Well, it's obviously going to be the tractor trailer, because the smart car has less mass, so it's going to be able to change that motion better or quicker because there's less laziness. Okay, and so the next idea is, there's all these examples that you talk about with inertia, but here's so we have an anvil attached to the ceiling, and we're going to buy a string, and then we're going to pull on the string. Okay, so really the question is, if I jerk down on the bottom string, which of the two strings is going to break? Okay, so you pause the video real quick and then you answer it. Okay, so now let's talk about the solution to this. So if I jerk quickly down on this, well, the bottom string is going to break right? Because what happens is the inertia of the block, right, or the anvil, will resist the pull, and the tension is transmitted upward through the thread, right? So because it's a heavy object, it's going to resist that downward jerking, right, that downward motion, okay? And then that tension is going to go up through, okay, thus breaking the bottom string. Now, if you go to the other side, what happens if I were to slowly pull it down, right, as opposed to quickly pulling it down? Well, the string that's going to break is actually going to be the top string, right? Because there's really because the strain on the top string will be greater because it's supporting the anvil and the pull of the bottom string, and so that's why that one will give out if we slowly pull. So a slow pull is the top string, a jerk is the bottom string. Okay, and why does that happen? It all has to do with inertia and how does that anvil resist the motion. Okay, so we're going to move on, right? So Newton's first law, we talk about law of inertia, law of equilibrium. Okay, object will remain in a state of motion unless you act upon by no net force or external force acting on it. Now we're going to look what happens when an external force acts, which is where we're going to focus on Newton's second